This is Floyd Marinescu, and I'm here with Jim Coplien and Bob Martin at the JIO conference. And here we have two very interesting, divergent opinions on what is the value of TDD. So we'll open up the floor and let each one have a couple of minutes of say, and then let's hear you guys talk about it.
Okay. So first thing I need to say is I'm sitting next to one of my heroes. I read Jim's book in 1991, 92. Changed the way I thought about software, changed the way I thought about C++ in particular. So it's a great honor for me to be here. I think we have a disagreement. I'm not sure. Possibly. It may be a difference in perspective. But my thesis is that it has become infeasible in light of what's happened over the last 6 years for a software developer to consider himself professional if he does not practice test-driven development.
Well, it may be good, because you did this at your keynote yesterday.
Yes.
You said what you mean by test-driven development. So, I've adopted a very strong position against what particularly the XP community is calling test-driven development. And I've audited this, versus a lot of tutorials at, at about 4 conferences, at Urs and Agil, at URDEV, at QCon, here, and one other in the past 6 months. And they give a very consistent story what they mean. Yours was a little bit different yesterday, so maybe for sake of making this a meaningful conversation, you can quickly reiterate.
Okay.
So we're on the same page.
So I have 3 laws of test-driven development. The first one is a test-driven developer does not write a line of production code until he has written a failing unit test. Right? And no production code can be written until there's a failing unit test. The second law is that you do not write more of a unit test than is sufficient to fail, and not compiling is failing. So you cannot write very much of the unit test before you must write production code. The third law is that you cannot write more production code than is sufficient to pass the currently failing test. So you cannot write a little bit of a unit test and then run off and write a whole bunch of production code. These 3 laws lock you into a cycle that is perhaps 30 seconds long. And that means you're actually writing unit tests and production code concurrently, with the tests perhaps 30 seconds to a minute ahead.
Yeah.
That is my definition.
And per se, the main concerns I have about TDD are not problematic with respect to what you just said in isolation. So if it's no more and no less than that, we may not have a big disagreement. What my concern has been comes out of doing broad work with a lot of clients and a little bit of interactions with other consultants and other Scrum Masters who've seen these things happening in their project. And the problem that we've seen 2 major problems. And one is that use of TDD without some kind of architecture or framework into which you're working, which was very strongly Kent's original position, right? You use TDD to drive your architecture, leads to a procedural bottom-up architecture, because the things you're testing are units. We just had a discussion upstairs about, is TDD the same as unit testing? Well, no. So a little more. But unit testing was a great idea in Fortran, when you could build these layers of APIs, and the units of organization of the software were the same as the units of testing. But today, the units of organization of the software are objects, and we're testing procedures, and there's a little bit of a mismatch. Now, if you're using the procedures to drive your architecture, I think you're trying to build a 3-dimensional structure from 2-dimensional data, and you end up going awry. And one of the things we see a lot in a lot of projects is projects go south on about their 3rd sprint, and they crash and burn because they can't go any further because they've cornered themselves architecturally. And you can't refactor your way out of this, because the refactoring has to be across class categories, across class hierarchies, and you no longer can have any assurances about having the same functionality. So, and the other problem we've seen is that this destroys the GUI. And this is what, what Trygve and I talk a lot about, is because you have this procedural architecture kind of in a Java class wrapper, you no longer are driving the structure of the system according to domain knowledge and things that are in the user's conceptual model of the world, which is where object orientation came from. I mean, even Kent, he's very often said, you can't hide a bad architecture with a good GUI. The architecture will always shine through to the interface, and I strongly believe that. And that's why I believe you need something in the infrastructure that gives you a picture of what the domain model is out at the interface. Then, if I want to apply, Uncle Bob's 3 rules, I probably don't have a problem with that. But I want a starting place that captures this other dimension, which is the structural dimension.
All right, but you do not accept the thesis that the the practice of test-driven development is a prerequisite to professional behavior in 2007.
No, I absolutely do not accept that. No.
So we can come back to that one because I think that's an interesting topic, just in the topic of professionalism. But before we do that, there has been a feeling in the Agile community since about 99 that architecture is irrelevant. We don't need to do architecture. All we need to do is write lots of tests and do lots of stories and do quick iterations, and the code will assemble itself magically.
Somehow, yeah.
And this has always been horseshit.
That's right.
Always been horseshit.
Thank you.
And I even think most of the original Agile proponents would agree that that was a silliness. I think if you went and talked to Kent now, he would be talking about, well, we always talked about metaphor, whatever the heck that was.
Yeah, and in fact, he says this in XP Explained or something. It's page 131 of his book. He says, yeah, you do some upfront architecture, but don't knock yourselves out.
Okay, but now let me come back and throw a different light on this. I think architecture is very important. I've written lots of articles and books about architecture. I'm a big architecture freak. On the other hand, I don't believe architecture is formed out of whole cloth. I believe that you assemble it one bit at a time by using good design skills, by using good architectural skills over the weeks and months of an iteration. And I think of many iterations. And I think that some of the architectural elements that you create, you will destroy. You will experiment in the first few iterations with different forms of architecture. Within 2 or 3 or 4 iterations, you will have settled into the architecture you think is right and then enter into a phase of tuning. So my view of that is that the architecture evolves. It is informed by code that executes, and it is informed by the tests that you write.
I do agree that architecture evolves. I do believe it's informed both by the code that you write and maybe even earlier by use cases that come in that inform you about things that are relating to scope and other relationships. But if you try to do things incrementally and do them literally incrementally, driven by your interaction with the customer without domain knowledge up front, you run risks of doing it completely wrong. I mean, I remember when I was talking with Kent once about in the early days when he was proposing TDD, and this was in the sense of Yagni and doing the simplest thing that could possibly work. And he says, okay, let's make a bank account, a savings account. What's a savings account? It's a number, and you can add to the number and you can subtract from the number. So what a savings account is a calculator. Let's make a calculator, and we can show that you can add to the balance and subtract from the balance. That's the simplest thing that could possibly work. Everything else is an evolution of that. If you do a real banking system, savings account is not even an object. And you're not going to refactor your way to the right architecture from that one. What a savings account is a process that does an iteration over an audit trail of database transactions, of deposits and interest gatherings and other shifts of the money. It's not like the savings account is some money sitting on a shelf in a bank somewhere, even though that's a user perspective. And you just got to know that there's these relatively intricate structures in the foundations of a banking system to support the tax people and the actuaries and all these other folks that you can't get to in an incremental way. Now you can, because of course the banking industry has come to this after 40 years. You want to give yourself 40 years, it's not very agile. So you want to capitalize on what you know up front. And take some hard decisions up front, because that'll make the rest of the decisions easier later. Yes, things change. Yes, architecture evolves. And I don't think you can find anyone who will say put the architecture in concrete. I also do not believe in putting the code in place, that is the actual member functions up front. You put the skin. You put the roles. You put the interfaces that document the structure of the domain knowledge. You only fill them out when you get a client who's willing to pay for that code, because otherwise you're violating lean. So you do things just in time, but you want to get the structure up front. Otherwise, you risk, driving yourself into a corner.
So I would say that a little differently and take exception to some of it. I would not very likely fill in the interfaces with abstract member functions or defunct member functions. I might create objects that will fill the place of interfaces. So in Java terms, I might have an interface something with nothing in it. But I'm not going to load it with a lot of methods that I think might be implemented one day. That's something I'm going to let my tests drive, the requirements drive, and I'm going to be watching it like a hawk to see if there's any kind of architectural friction that would cause me to split that interface.
But the problem is that's like saying that words have meaning apart from any definition. And so the fact that I call something a mule, without saying what a mule is, doesn't make it a mule. And like Abraham Lincoln says, calling a mule an ass doesn't make it one. And so the thing that gives meaning to stuff is the member functions, the semantics. Now, yeah, you don't want to go crazy, and you don't want to be guessing. And here's where I agree with Kent. He says in the XP Explained book, he says, you don't want to be guessing, and that's true. But I do want to assert what I know. And there's some things you just know about the structure of a telecom system, a banking system. You know that you don't build a recovery object. I was on a restructuring project in a large telecom company once where they were redoing a toll switch and using object-oriented techniques and modern computer science techniques. And I got assigned to work with the guy who was making the recovery object. Well, this is ludicrous. Recovery isn't an object. But yet his superficial knowledge of the domain led him to that. Now, if you get down to understanding what the member functions of that are, then you'll see this isn't even an object. So you ask, well, how do I know it's not an object? Well, what are its member functions? To recover. Well, okay, great. That's a lot of help. Actually, I think there's people who've capitalized on this, and it's now called SOA. But that's the danger. You want to have something there to give the object meaning.
Okay. And I would even agree with that. You need something there to give the object meaning. I'm going to be really minimal about that.
Me too.
Okay, good.
No disagreement.
Good. And then I'm going to let executing code inform my future decisions.
Yes.
So I'm not going to create a massive architecture or a huge system based on speculation.
That's right.
Okay.
No disagreement.
All right, so back to the beginning. How long would you spend before you started writing executable code on let's say it's a system that will eventually wind up being 2 million lines of code?
So 2 million is, in my experience, pretty small.
Nowadays.
I'm working with hundreds of millions. Before the first executing code, so I don't know. It depends a lot on the individual system. But let's say I were building, again, a simple telecom system. What I would probably do, let's say I'm doing it in C++, telecom systems you often are, I would have at least constructors and destructors in place and be able to start to wire up important relationships between the objects.
Okay.
And that's going to happen.
Would you have tests? Testing those wirings?
I would have tests for those wirings,
yes, okay. All right.
To make sure. An obvious test is to make sure when the system comes up and goes down that memory's clean, for example.
Great.
Half an hour.
Excellent. Okay, so where is our disagreement? Perhaps our disagreement is on the notion of TDD and professionalism. So that was the second talk. That was the second.
That's the second part.
Part.
I think that's a separate disagreement.
Yes.
But okay, fine. Well, maybe we can put this one to rest. This is nice.
Okay.
But I mean, the thing I want to make clear, for the audience is that, again, I think that when I'm running into people who are doing things right, that avoid the kind of problems I talked about earlier, it's not TDD out of the book or TDD out of the box. So people have found a way to move to what Dan North now calls BDD,
right? Okay.
For example, which I think is really cool if you ignore the RSpec part and all the stuff which is kind of dragging it back to too low of a level. So there's a lot of people doing the right thing, and my concern is they're calling this good thing TDD, and then people are going to buy books and they're going to look up TDD and they're going to find this old thing, which is architecture only comes from tests, which I've heard 4 times in tutorials in the past 6 months, and that's just, it's like you say, it's horseshit.
Yeah, okay.
But now, on to the professionalism thing.
Okay, yes, all right.
How would you know a professional if you saw one?
They practice TDD.
Professional to me is just someone who makes money for doing a job in that area.
Yeah, no, I'm going to push on that one because I think that something our industry has lacked is a standard of professionalism.
We'll take your definition as a starting point, and then we can talk about that.
Okay, well, that's not actually my definition. I was joking. I think that nowadays it is. Let me rephrase it. It is irresponsible for a developer to ship a line of code that he has not executed in a unit test. And One of the best ways to make sure that you have not shipped a line of code that you have not tested is to practice TDD.
Yeah, and I do disagree with that.
Okay.
Now, I think there's something deeper that is important. And let me attack this by example. As an example of something I could do as an alternative. Now, I could wave my hands and say a lot of things about code inspections or pair programming. And those are good and probably have more value, but it's kind of an independent discussion. But let me give you something that I think hits the nail on the head even more importantly. And let's look at what a unit test is. What a unit test does is looks at an API of a procedure and kind of goes and hits the state space of the arguments, and maybe hits a half a dozen of them, or 100, or a few million of 2 to the 32nd or 2 to the whatever. And so you're just doing hit and miss. And yeah, that's really, really heuristic, and you got to really be lucky to find bugs doing that. What I think is more powerful is design by contract. So you have preconditions, postconditions, and invariants. Now, the technology isn't there yet in most languages. They haven't matured to the point where Eiffel has, where you can statically check these things. But you can build additional infrastructure to do that kind of thing. I think it has all the advantages of TDD. There are these advantages, supposed advantages, but I'm going to think hard about the code. I'm going to focus on the external view and so forth. And I have found, at least for me, that contracts do that more effectively than tests do. Furthermore, they actually give you broader coverage because you're covering the entire range of the arguments rather than just randomly scattering some values in there. Now, Bertrand Meyer has actually taken this further, and he has something called CDD, which is contract-driven development, where what he does is he takes contracts and he kind of feeds random numbers at them, and if they don't meet the preconditions, you don't run them because that test will fail. But he tests then if the postconditions hold after you run the test, and if they don't, it's a bug. And they've actually done this. They have a tool that automatically runs tests. They've done this on the Eiffel library, and they ran it about a week. They found 7 bugs in the 20-year-old Eiffel library. Now that's kind of interesting. But it comes from a part of the code where you're expressing intentionality in a way that has hope of being traced back to something of business importance. And the problem about TDD, as most people practice it down at the class level, is it's really, really difficult to trace those APIs at a class level sometimes all the way up to business significance.
So I'm having trouble with that. As I remember Eiffel, and I actually thought this discussion was put to bed a long time ago. As I remember Eiffel and design by contract, you specified preconditions, postconditions, and invariants around every method.
Yep.
And around your class.
Well,
the invariants in the class.
The variants of the class,
okay.
Yeah.
Test-driven development, or a suite of unit tests, virtually does the same thing. It specifies a set of incoming checks on the arguments, outgoing checks on the return values, explores the state space, as you said, of the methods. So I always thought that they were one-to-one. You could always transform contracts into unit tests, or always transform unit tests into contracts, with the exception that the direction of the dependencies is different. And I'm a big dependency freak.
Yeah.
Unit tests depend on code, on production code, which I think is good. Production code doesn't depend on unit tests, whereas contracts are smeared through the code, which bothers me.
But I think you're creating a dualism that needn't be created, is that there is one thing, which is the code. The code is the design. It's what's delivered. Anything else is not lean. If you have, in typical projects that use unit testing, the code mass is about the same as the test mass. And where there's code, there's bugs. You cut your velocity in half. There's well-known examples. The most famous example is the Ada compiler, where actually use of test-driven development increased the number of bugs in the code because your code mass increases because you have more tests. If you're using assertions, you have this nice coupling that's essential coupling between the semantics of the interface and the code itself, whereas the tests, the coupling is a lot messier and hard to manage. So there was another point you had made I was going to react to.
I'm surprised that you think the code mass is different.
And in my experience, it is. If I look at how people actually use this, I like it when I see a JUnit spec that looks like assertions, but a lot of the time it isn't. They're just
okay, and I agree with that. There are messy tests.
Yeah.
Okay, but there's messy code.
Yeah.
I don't like arguments that the tool is easy to abuse, therefore you shouldn't use it. That would have invalidated almost everything.
That isn't my argument. My argument is how I'm seeing this being used in broad practice.
Sure.
And
Sure.
they're not getting it.
Well, okay. All right. And do you see contracts being abused in broad practice? And
well, first of all, they're not being used enough.
Okay, right.
Right?
By the way, since we've just got a couple of minutes left, just a trivia question, and I don't know the answer. Who is it that first used DD with some letter in front of it? We've got CDD now, we've got BDD, we've got TDD, we've got I don't know what else. And the earliest one I can remember is Rebecca Werfsbach, Responsibility-Driven Design. Was there an earlier one?
Oh, so not even driven development, it was driven design.
Or DD?
DD. Well, it was a Unix command to do dist-dump. Well, that probably doesn't count. Thank you, Bob. Good seeing you again.